Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Kurdilan Said from the Maths Department of Senior Girls Wing APS 4 Road Rawalpindi. I welcome you to the online support program daily video lesson of Maths for grade 8. This lesson is basically about your third week's assignment. As you know that we are continuing the same book in grade 8 that you have already studied in grade 7. That is New Syllabus Mathematics Book 2. Let's come to the topic now. Our today's topic is expansion using special algebraic identities. Well, the term expansion is not something new for you, as you have already learned to expand the product of algebraic expressions in your previous maths assignments. In today's lesson, you will learn to expand the algebraic expression by means of some special identities. How are we going to achieve this objective? A. By identifying the identity correctly. B. By applying the identity correctly. So both identification and application are very important. No matter how perfect our application is, if we have used a wrong identity, we would never get a correct answer out of it. Now here is the question that may arise in your mind, that what an identity exactly is. Basically, an identity is an equation, but it is such an equation which is true for every value of the variables involved in it. For example, this equation x plus y is equal to y plus x is an identity because whatever value you substitute for x and y, its left hand side will remain equal to its right hand side. Suppose you take x as 2 and y as 3, the sum of 2 and 3 will be the same as sum of 3 and 2. So such an equation is an identity. Now there's some food for thought for you. You have to answer this question. Is every equation an identity? Think upon it. Let's begin with the first identity. As we know that the square of any number can be written as its product with itself. So we can write x square as x multiplied by x. Similarly, the square of a plus b can be written as a plus b multiplied by a plus b. The next step is to simply expand this product by distributive law. That is, the first term a of the first expression is multiplied with the second expression. You get a times a plus b. Then the second term b of the first expression will be multiplied with the second expression. Then you get b times a plus b. Then we have to solve these individual products to get a squared plus ab plus ab plus b squared. Here clearly the middle two terms are alike, hence they can be added to each other to give us 2ab. So the expression is a squared plus 2ab plus b squared. This completes our first identity, that is a plus b the whole squared is equal to a squared plus 2ab plus b squared. Now let's move on to the second identity. Similarly, we can derive the second algebraic identity by first writing the square of a minus b as a minus b multiplied by a minus b. Then we'll expand this product by applying distributive law, a times a minus b and then minus b times a minus b. Expand these individual products, we get a squared minus ab plus b squared. Solving further, we get a squared minus twice ab plus b squared. So this is our second identity. Since both of these identities are of squared form, so collectively we can call them perfect squares. Clearly we can see that the first identity is actually the perfect square of sum of a and b, and the second identity is the perfect square of difference of a and b. Basically, these identities will help us to expand the algebraic expressions which are of the same form as that of the identities. Now let's practice the application of these identities one by one. The first situation is expand 3x plus 2 the whole squared. Clearly we can see that it is the perfect square of sum of 3x and 2. So definitely it's the case of first identity. Then we'll compare the given expression to the left hand side of the identity to identify the values of a and b. This suggests that a must be 3x and b should be 2. Inserting these values of a and b in their places in the right hand side of the identity, as you can see on the screen, Remember that the square is also on the coefficient of x. That means you have to take the square of this 3 as well. So you get 9x squared plus 12x plus 4. This is the final step of expansion. Now let's take another example of application of identities. In the same way, we can apply the second identity. For that, first we'll make sure that the given expression is the perfect square of difference of two numbers. Fine. Then we'll write the second identity. We'll compare the left hand side with the given expression to identify the values of a and b. In this case, a is 3q and b is 8r. Insert the values of a and b in their places. Solve the individual terms by solving the operations involved. Don't ignore the coefficients while taking the squares. So final form is 9q square minus 48r plus 64r square. Another important point is that we'll not insert b as minus 8r, because if we compare the given expression with the identity, we find that minus b equals minus 8r. That means b is 8r. Now let's move on to the third identity. The third identity is actually based on the product of sum and difference of a and b. We expand this product by distributive law as we did earlier. A times a minus b plus b times a minus b, as you can see on the screen. Now further expansion will result in a squared minus ab plus ab minus b squared. We observe that the middle terms are same here but opposite in sign, so they cancel each other. Hence we are left with the squared terms only. This is our third identity and it is called the difference of two squares. Now let's take an example for the application of third identity. The question is, how would we know that where to apply the third identity? Firstly, it will be a product of two expressions. Secondly, one expression will be a sum and the second will be a difference of two same terms. Here the terms are 7 and 2u. You can observe that the terms in both expressions are same. So this suggests us to apply the third identity. We'll write down the identity, write down the given expression under it, compare the two expressions, identify the values of a and b. Here a is 7 and b is 2u. Insert the values in the right hand side. The first term is a square, so here it must be 7 square. The second term is b square, so it must be the square of 2u. Then solve the squares on each term. 7 square is 49 and 2u square is 4u square. Here is some further application of algebraic identities, especially in the situations where the use of calculator is restricted. For example, finding the square of 103. We can easily split 103 as the sum of two numbers whose square is known to us, that is 100 plus 3. So it becomes the perfect square of a sum. Clearly, it's the case of first identity. You will write the first identity, compare it with the square of 100 plus 3, identify a and b, and insert those values of a and b in the right hand side, a squared plus 2ab plus b squared. Solve the individual terms. We get 10,000 plus 600 plus 9, and hence adding up all the values we get 10,609. Similarly, for finding the square of 497, we can think of writing it as sum or difference of the numbers whose squares are known to us. So we'll write 497 as the difference of 503. Clearly, it becomes the case of second identity. We'll identify the values of a and b. A is 500 and b is 3. Insert the values of a and b in the right hand side, a squared minus 2ab plus b squared. Simplify all the terms and adding up the terms to reach the result. Next is another situation when we are given a product of two different numbers, but those numbers will always have something in common. Like here, 201 is 1 more than 200 and 199 is actually 1 less than 200. So we will definitely apply the third identity here. On comparing, we get that A should be 200 and B must be 1. Then solving the squares of 201 and solving their difference, we'll get the answer. So this is all for today. Let's move on to the assignment for the third week. You can go through it, and here is some written work as well. I hope you find this lesson effective and helpful in solving this assignment. I wish you all the best, and thank you for listening to me with patience. Allah Hafiz.